In this troubleshooting case study, we have exactly the same trouble ticket that we had in our previous case study. Specifically, PC1 is unable to reach this host out on the internet, and we want to use the same basic strategy for tackling this issue. Let's begin by making sure that we're interpreting the issue correctly. My interpretation is I will be unable to ping 203.0.113.1. Is that true? It looks like the pings are failing. We've confirmed the issue. And on the real exam, if you had a PC simulator, you might now issue the ipconfig command to make sure that you had an IP address, to make sure your default gateway is correct, it matches up with the given topology. And maybe on the real exam, there's a router acting as a D8CP server. Maybe you haven't obtained an IP address via a D8CP server. You would need to start troubleshooting things between the PC and whatever router is acting as the D8CP server. In our case, though, this PC, which is actually a Cisco Catalyst switch, is hard-coded with an IP address. But we've confirmed the issue. We're unable to ping this host out on the internet. Now, using the strategy we saw in our last case study, I'm going to start to follow the path. Let's first see if I can get to my default gateway. Let's do a show IP route. This will tell me that my default gateway is 10.1.1.1. That's correct. Can I ping 10.1.1.1? Those pings are failing as well. Interesting. Well, this is somewhat good news because we've isolated where the issue lies. It's probably not some routing protocol or route redistribution or something like that. I'm unable to get to my default gateway. I need to start troubleshooting issues between my PC and DSW1, which is my default gateway. Well, the first thing I want to do is go to my next hop layer 2 device, which is my access layer switch, ASW1. Looking at our topology, we see that we should be connecting into ASW1 on interface Fast Ethernet 0/1. Let's go to ASW1 and let's do a show IP interface brief. Let's make sure that Fast Ethernet 0/1 is in the up state. And it is. We're up at layer 1, we're up at layer 2, that's great. And I'm also noticing on this topology that PC1 is supposed to be a member of VLAN 1. Let's check the VLAN membership, because if we were assigned to some other VLAN, that might explain why things aren't working. Let's do a show VLAN brief. Is Fast Ethernet 0/1 part of VLAN 1? It is. This port is in VLAN 1. Great. Next, I'm noticing that there is an ether channel going between ASW1 and DSW1, and there may be a trunk on that ether channel. Oftentimes we do have a trunk configured for an ether channel. Let's see if we do. Let's do a show interfaces trunk command. And notice that for port PO0, port channel 1 in other words, we are currently trunking. Here's my encapsulation. I'm allowing all VLANs over this trunk, and this trunk I assume is going to DSW1. Let's do a show CDP neighbors command and just confirm that. Yeah, DSW1, we've got two physical links which are combined into this virtual port channel 1 interface. They appear to be up and happy. Everything seems to be good at this point. Let's now continue to follow the path and go to DSW1. On DSW1, let's check the trunk there. Let's do a show interfaces trunk command. And I want you to look very carefully at this output. Let's compare this output to the output we had on ASW1 when we issued the show interfaces trunk command. Do you notice a difference? This is ASW1, this is DSW1. Do you notice that VLAN 1 is not allowed on this trunk? From the perspective of DSW1, it was allowed on ASW1. We were allowing all of our VLANs. On DSW1, I'm allowing specific VLANs, 100, 200, 300. That would explain why VLAN 1 traffic is not getting through. Let's see what kind of configuration we have on this port channel. Let's do a show run interface port channel 1. And look at this. Switch port trunk allowed VLAN. We are explicitly allowing VLANs 100, 200, and 300, and all other VLANs are going to be blocked. We're pruning off all of those other VLANs. Well, that's not what we want. We want to allow all of our VLANs, including VLAN number 1. Let's fix this. Let's go into interface configuration mode for port channel 1, and let's say switch port trunk allowed VLAN, and let's allow all of our VLANs. And it might take a few seconds for VLAN 1 to become active. Let's give it a few seconds and we should see an indication on screen. Remember, for a switch virtual interface to be active, we have to have at least one port belonging to the VLAN associated with that switch virtual interface in the up state. And that port can be a trunk port that's carrying that VLAN. And here we have this SVI, interface VLAN 1, its state just changed to up. Great. Let's now go back to PC 1 and see if we have connectivity with this host on the internet. Let's once again try to ping 203.0.113.1. Success. Our issue in this case study was a layer 2 issue. We were pruning a VLAN off of a trunk that was formed on an Ether channel that was interconnecting ASW1 and DSW1. And I'll see you back in a moment for our next case study where, no surprise, we're going to be facing the same trouble ticket but with a different underlying issue. I'll see you back for that in just a moment.